Our next speaker is not only editor-in-chief of Hackaday, he's also a full-time orchestra musician. And this is his chance now to give you guys an inside view into what we think are the most important issues in the world facing hackers and the general public. Mike's State of the Hackaday speech is always inspiring and always thoughtful, and I presume it will be again today. So please join me in welcoming to the Hackaday Supercon stage, Hackaday's editor-in-chief, Mike Szczys.
Appreciate it. Good morning. Giving the first talk on a Sunday morning of a conference like this is always risky because I think people were out having way too much fun last night. So thank you for showing up. I know it was a little bit rough, but boy, having this on the time change weekend and getting an extra hour is clutch. So I got to say, it is impossible at this point for one person to stand up and talk about all of the things that Hackaday is doing and the motivations behind them. There are just too many amazing people that are really, putting in the effort and the blood and sweat and tears to make Hackaday amazing. And this is all the way from people that contribute an article once in a while to the people who are working full time to make sure Hackaday.io is running and awesome. The people that are planning conferences like this and doing original art and original music for it. And to tell you the truth, I don't know how we pull off all of this. And that's because there's so many great people involved, all the way down to just the community members. I've been approached by 50 people this weekend. They're like, hey, I didn't volunteer, but if you need anything, let me know. I'd love to help out. And it really is that hands-on nature that makes the Hackaday community special and important and worth supporting and worth taking time of your own life to come and be part of. And that's what I'd like to talk about today is like, what is it that makes us a community and what effect does our community have on the world and how can we kind of use our ethos and our energy to shape things in a positive way. I read a ton of science fiction and one of the authors I respect most is Neil Stephenson. And if you follow him much, he's been talking a lot lately about getting people to stop writing dystopian futures because those futures are inevitably going to come true. If you assume bad things are going to happen, you're going to find a way for bad things to happen. And the great thing about us is we assume that good things are around the corner as long as we make sure that that comes true. I want to open and close today with a couple of different anecdotes. And the first one is about me. And I always wanted to be an engineer. But I also always wanted to be a musician. And it was a difficult decision, but I ended up going to music school and got a couple of music degrees. But along the way, I built some dumb robots. I built some a little bit smarter robots. I learned about microcontrollers and really got lost in that for a few years. I learned about making circuit boards and making things that blink like this hand-soldered LED matrix. I started tearing apart cell phones and reverse engineering the parts in them to see how they worked and then using in my own projects. I built a pretty ridiculous Wi-Fi enabled hat and asked people to hack it at conferences, wore it around in public if you consider DEF CON public. I went down the rabbit hole learning about the logic used in the ghosts for Pac-Man and then like rewrote Pac-Man for a esoteric display. And I was like, hey, this digital stuff's interesting, but what about the non-digital stuff? And started working with analog circuits. And then this summer I was like, I haven't really manufactured more than 5 of something. Can I make 60 badges in my basement? And the answer is yes, and you should not want to do that. It was a lot of fun. But I still work as a professional musician. This is actually my wife, Amanda. She's a bassoon player as well. And so really the question is like, am I doing this wrong? Like, what am I doing with all this engineering stuff and being really excited in science and then not working in that? And I think the important thing is that we live in a society where you need to be scientifically literate. Like, you need to have an idea of how things work, even if that's not going to be your job, even if you're not going to be responsible for those things. And because that gets buy-in from people, and buy-in across all of our society and across all of our cultures is key to future successes. There should not be a separation between the people who understand how things work and the people who make them work and the people who use them. That's depressing. If you think you have no power and no influence over the things that you're depending on and the things that you want to use in your life, what value does that have to you? And I think that's one of the problems that we're facing right now is people feel separated from their technology even though they're so closely dependent on it at the same time. It's really a mix of experiences that we should be seeking. And I think there are a lot of opportunities for that type of engagement. We should be an inclusive community that welcomes people with skills across all levels. I'm not saying that we should, dilute down what it is to be elite and to be really good at something, but I'm saying we should bring up and close the gap on who can be involved and who can be parts of these teams. I was really delighted to see Bill Gross's keynote yesterday because he talked about a lot of this. He said, look, it takes all of these people with all these different skills. If you have the greatest solution in the world, but you have no opportunity to enact it, what use is that solution? And I think that buy-in across society is what's going to give us the type of opportunity for it. So I think our goal, our underlying goal across everything that we do should be to make sure that society understands the technology, society understands scientific principles, and can use that understanding and that base level to make good decisions, to think critically, and to make the choices that need to be made in the world that we're living in. If people don't understand how things work, that kind of takes on the mantle of magic. It might as well be magic. And having things be magic is really dangerous because when a problem comes up, then they think, well, you can just magic that away. And the other thing is people that deal in magic have had kind of a bumpy past. And so we do need to watch out for that. If you don't have a basis to look at something and decide if it's a good choice or a bad choice or understand how it works at all, you can't be involved in those decisions. And again, that divorces people from feeling like they have control. And we need to avoid that at all costs. We know difficult solutions are needed. And so I think in order to guide those solutions within society, we need people who can look at the two difficult options and pick the one that's the best for everyone. At the same time, I think it's really important that we pick the greatest minds that we have and we continue to engage them and elevate them. I think people that work in engineering, one of the things that I hear from them is, like, boy, I learned a lot in college and then none of it was applicable to my job, and it's almost like I had to learn a whole new scope of everything. The other thing that I hear is people get into one role and you do kind of the same thing over and over again. You become really specialized in that, and then you have to really consciously work to keep elevating those skills and keep up with the technology and the state of the art. And so I think a huge thing that Hackaday can do is be an engine of engagement for people that are already working in engineering fields so that they continue to improve and when we need people to make breakthroughs and to make huge discoveries, we have a larger pool to do that. So, and looking at how Hackaday kind of promotes that engagement, a huge way is contests. And I always look at our contests as like a playful way. It's like the spoonful of sugar that goes along with the pill. And we had a lot of good ideas this year. I love Joe Kim's art. Is it just amazing? So Joe Kim did the art for the Coincell challenge this year. This is a really fun one. The constraint was like, build something with the Coincell. Like, what can you do with the Coincell? And the thing is, if you're working at your bench all the time, you have like a bench meter or bench power supply, and you really never think about the juices that's coming through until you make sure that you don't burn something out, or eventually you're going to be like, okay, it's going to work on batteries. But if you start off and you're like, okay, we need you to get a huge bang out of this little buck, I think that starts to just scratch at people's brains. It starts to make them look at like, what parts am I using? How can I really look at low power? And by playing in this sort of realm, if we go to design consumer products and that sort of thing, you're already going to have an idea of what is going on with that. And so I think it's powerful that way. And of course, I loved the entries that we saw. So in the upper left, this is Jaromir Sukuba's winning entry, which is a global positioning system that can run for theoretically like 30 years. And the way it works is it's just got an accurate clock in the microcontroller and then a light-dependent resistor. So it measures sun up and sun down, and you can find where you are on the planet with that. And so then when he built it, he's like, and it's like within 2 kilometers, which I think is great. And then he's like, I better test this. And instead of like driving all over the world to test it, he found some people on Hackaday.io and like mailed it to them, which is great. So I talked to Ted Yapo yesterday. I didn't realize that either of these were his, but there's 2 of his here. He tried to jumpstart a car with a Coincell battery. Theoretically, there's enough power to do it. Didn't quite get it, but it's a good read. And then he was measuring how many screws he can screw into a piece of wood with it, which I think that empirical testing is great. And then, of course, we love seeing the sparky stuff. So someone built a railgun with this. So who here has a 3D printer? Who here has printed a useless trinket with their 3D printer? Who here spent most of the first couple weeks printing useless trinkets with their 3D printer? Okay, so we ran the repairs you can print contest to kind of break that cycle and be like, hey, find something that it would be difficult to repair you can't find the part, it's not available, whatever, and do it on the 3D printer. I think this is a really interesting way to put the challenge, because what it actually gets people to think about is supply chain. So if you build a product and you're expecting people to repair it, it means you're either going to have to do an overrun of those parts and warehouse them somewhere and have a way to connect them with the customer, or you're going to have a way to get them on demand. Neither of those are great. But if we have the ability to model the parts that we need and then have them be printed as people can use them, it has a lot of power. And we saw some interesting ones here. You could just get a universal remote when your dog chews the remote, or you could print it like this. So I think that's interesting. If you break the case on your tool, you're going to throw the whole battery away. So to replace the case and keep the cells is good. But definitely my favorite is if that bottom zipper stop thing comes off on your jacket, when you unzip it and you have your zipper in your hand, you're probably going to throw that jacket away, right? You're not going to take it to a tailor and have them replace it. But you could put this plastic part on it one time and then make that jacket go another winter or two. I think it has a lot of power. So both of these, the Coincell Challenge and the repairs you can print, they require a fair level of investment and knowledge, because you have to be able to 3D model and figure out power curves on batteries and that sort of thing. But I think there's a lot of places to engage people and welcome them in a little more. We see Raspberry Pis, especially like the Pi Zero is like a $5 computer, has taken off like wildfire, which is great. But I see a lot of them that are being used as like desktop computers or being used as like game emulators, which is fine. Get into the technology, really love it. But we said they have a header on there where you're supposed to hang off some hardware. So what can we do with that? And we challenge people to hang a LED strip or a matrix and just do something blinky. A couple of the winners that we saw, like a huge Tetris display that hangs on the wall and a fuzzy clock on like a commodity panel. And I think giving opportunities for people across all skill levels is a way that we can, keep people leveling up and keep them engaged. We also, one of the most popular contests we've ever run is the Square Inch project. It was actually community conceived out by Alpha Ninja on Hackaday.io a couple years ago. And we brought it back this year. It says, what can you do in 1 square inch of circuit board? And go and look at over 100 entries, I believe. Amazing stuff on this. The winner is a little DC motor, cheap little motor that has an encoder added to it and a precision driver, and you get a lot of the benefits you get from a much more expensive like NEMA stepper motor in a really cheap motor. And I think we're going to see a lot of benefits in robotics over the next few years by these kind of projects, because they're popping up again and again and again and getting better every time we see them. The other thing is silicon manufacturing is to me, I talked about magic a little while ago, but the stuff that they're putting on chips these days feels magical. We got to catch up with how they're actually doing it. And one of the ways is to take these chips and put them in a board that you can work with the instructions and the breadcrumbs for you to actually figure out how to get in there and play with it. And I think that demystifies that magical part of it. For $25, you can have a spectrometer on a square inch of circuit board, and you look at that, and maybe you're the one that makes the next board with the new line of chips. So I think there's a lot of power there. And of course, the biggest bang for the buck is the Hackaday Prize. We have huge buy-in from around the world. People that have entered in the past amplify that message and say, this is great, go and work it. We have a wonderful set of sponsors that comes back year after year after year and really gets behind this and drives it. And we have great enthusiasm for it on the Hackaday team. Everyone that was here last night and saw the award ceremony and talked to any of the winners that were here knows that getting people to set aside a little bit of time in their lives to think about solving problems that will have ramifications for everyone is a powerful message. I think it allows us to become the shoulders on which the next generation will stand. So working on this and putting it out there and showing what you're doing is really important. And that leverages our community. And it's important to note that I think the majority of Hackaday comes not from people who are working as Hackaday staff, but for the community themselves. I mentioned that Square Inch project is a community-conceived project. One of the ways that I think the community is important is by normalizing engagement in science and engagement in engineering, making it so that you don't have to have a special, we have to sign up for a class and go take it at the university and in order to be involved in this stuff. It should be more of a casual interaction. You should be able to talk about high-level things for fun. And so we've been running the Hack Chat for a couple of years. Every Friday at noon, we bring in someone from a different walk of life who's an expert in something and has experience, and we just have a text chat and talk about it. It's scheduled for an hour. They almost always go for like 2 or 2.5 hours. And it gives you the chance to like explore cross-discipline ideals. So a lot of times you get, like I said, into a job and you're like really good at this one thing. Getting that out there and exploring what's going on and pollinating those ideas gives us the ability to expand and do a lot more. I think we're going to see a lot of exciting things with that in the coming year. We're actually going to move the weekly Hack Chat to midweek. I believe it'll be Wednesdays. We'll put out a lot of messaging on this in January, but we're going to keep that Friday slot open and do some new things there. So I'm pretty excited about that. Also, on Hackaday.io, we noticed starting a little more than a year ago, there were a lot of people that were like, hey, I want to have a chat for my own topics. And so they started projects like a chat for drones and a chat for music. And over the last year, we saw the FPGA chat come up. And there was kind of a barrier there at first, like the chat rooms were private, so you had to request to join and then be added. So we got that opened up. There are public chat rooms now, so you can start a project with any topic you want. Have a public chat room, go recruit people to come in. And what that ends up being is you may need a solution for a specific thing, and the people in that chat room might not have the solution, but they know where to go to get it. And so it becomes like a search engine for the unsearchable, and it also breaks down that, that formalism. So it really kind of normalizes the ability to just go in and be like, let's have a high-level conversation about this stuff just to geek out about it. Also, this year we added the ability for users to make their own lists. And so this slide is a bunch of lists that are user-generated, and we get to see the niche knowledge that people are really excited about, and they go out and find these projects and start these little communities. So check out the user lists, give them a try yourself. I think Hackaday is widely known for our editorial platform, and really what we strive for when we're writing articles for Hackaday.com is starting the conversation. So finding the topics that are important to the Hackaday community, getting as much information and digging down into the engineering side of things, and then opening it up for that conversation and seeing who appears in the comments. And we see people from all walks of life appear in it. We will tell stories about like old Silicon designs, and that one of the hardware engineers that were involved in that will like pop up in the comments and be like, oh, I was on that team and we did that for this reason. So it's really cool to see who's in there. It's always worth scrolling down in those comments and participating yourself. One of the things that we've been doing this year is focusing on stories that are getting attention in wider media that have really deep engineering topics that aren't being explored. So you might hear the news, but you never hear the details of it. So things like the Digital Millennium Copyright Act has stipulations about what you can and can't do with hardware that you have paid money and supposedly are the owner of. That law is still law, but every 3 years they have a review of exemptions. And so that 3-year review just came out, and Elliott Williams like jumped into that and really drilled down and said, here's the good things and here are the things that are not so good in it, and we should keep, and, gave some advice on how we can keep advocating for that. I think there is a new space race going on right now, and it's really fascinating. It's just fascinating to see the juxtaposition of private industry going into space and still state-level actors going into space. And so I often think, like, how many people were working on, like, the Apollo programs, and how many people are working on, like, the SpaceX and the Blue Origin programs? It's amazing to think about the productivity level that we've boosted up on these really hard projects. But recently, there was an aborted launch with the Soyuz capsule, and like everybody on that team performed amazingly and went through what they had trained, and it was a safe landing, and everything turned out. And if you listen to that, like the cosmonaut, did they call them cosmonauts? The Russian astronaut was like totally ice in your veins, calm through the whole thing, and like making jokes. And I'm like, that is impressive. But Tom Nardi realized right away that the biggest problem was not that they didn't get people up to the station as much as it was that they didn't get the capsule up to the station. There's a ticking, there's a timer on those capsules because they have caustic fuel in the fuel tank. And so the one that's attached to the space station right now is only good for a few more weeks. And so what it means is once that leaves the station, they won't have another way to get the people who are on the space station right now back to Earth. And so they really needed that capsule up there. Now, there was just another launch this morning that was successful, unmanned, and so we think they're going to actually send that up there. But what it would mean is if they don't, we could leave the space station uninhabited or unmanned for the first time since the year 2000. And so, it's kind of like a symbolic thing. They wouldn't lose the space station, but like drilling down to that story, like there's a lot more going on here than just one aborted launch. I think that's interesting. Jenny List did a great job of picking up on some rumblings from the FCC on hardware that's being sold. So this is a radio that is kind of going outside of the allowable transmission bands. I believe if you have a ham license, it's fine, but this is kind of being sold to anyone. And I think the issues that go around that are important. And of course, I would bet most people in the room read this article. Have you read this one? Brian Benchoff wrote. So the Intel management engine is kind of like a black box inside of your Intel chips. And earlier in the year, I guess at the end of last year, someone found an exploit within it, and it's like in every chip. And so looking at what the ramifications are about that, it's really hairy. And so Brian did a great job of drilling down and giving you the base things that you need to know in order to go and learn more about it. So those are the kind of serious stories that we've been working on. We do like the playful stories a ton. And so if you get the chance to go into a big box store after it's abandoned by its bankrupt parent company and see what was left behind, that's a lot of fun. We have a great writer who just joined us named Drew Luttrell, who's drilling down on this series about copy protections on old video game consoles, and it's fascinating. I think there's another one coming out either this week or next week on like PlayStation stuff. This was a Blockbuster video, had a pilot program in the 90s to like burn game cartridges on demand. It's pretty fascinating. I did mention how we want to kind of normalize science and involvement in science. And on the previous State of the Hackaday, I came out with the idea that we like turn our sports stars into like gods and goddesses, basically, and I think we should be doing the same sort of thing for people that are making great scientific discoveries. And so we've been doing what internally we call profiles in science. The discoveries that all these people have made. They've made amazing discoveries. You likely don't know their names or their backstory. And so it's really difficult to dig up, like, who was that? What was that story? So if you have stories of people you think we should be doing biography profiles on, please let us know, tips@hackaday.com. And we'd love to elevate those people. But go to the biography category and you'll see, I think we're well over 100 of these at this point, and we keep doing them, which is a ton of fun. Also, growing up the skills that you need for your next hack or to get better at the projects that you're working on has been a big push this year. So we ran a series of articles on Python. And these are a lot of things that you probably already know, but those kind of like scary edge cases that you already stay away from because you think you'll get bit, like these articles go into that and really help you with it. I think Pitfalls of C pointers is one that I've read like 2 or 3 times already. And I always think, well, I finally learned pointers, but then you're like, oh no, it's gonna reach out and bite you. Maybe screw up your puzzle on the badge if you're not lucky. And then drilling down on the more pedantic and absurd things is a great hobby and pastime of the Hackaday writers. So this was, Tom covered this one. There was a person named someone. I don't remember the actual original hackers project on this, but they did amazing amounts of testing on Crimp Connections and came up with the thought that you should just buy your cables because you're going to get a better system like that. But of course, that wasn't good enough. So Dan Maloney kind of went down the rabbit hole on like crimp ferrules and the problems with those. This was after a 3D printer had fire problems. It was traced back to the ferrule. And then definitely my favorite in this whole ridiculous series was Jenny List is like, okay, you can get a $2 crimper, or you can get a $200 crimper, or you can get like an $80 crimper. And she went through and did like empirical testing of all of them, electrically and mechanically, to the point where she like set up a ladder and hung the crimped connection from it with a bucket and then slowly filled it with water to see how much water it would take for it to break the mechanical connection on it. And it's not just the crimp connections that we went after. This is a good one. So I am probably not guilty of calling everything a JST. I call everything a Molex connector, even though it's not. And Roger and I were talking about it. He's like, it's my pet peeve. Nothing is a JST connector. That's the name of the company. So he actually went in and told us what these connectors are. I think connectors are some of the hardest things to source. And I always see people on Twitter, they're like, does anybody know what this is? And so I think it's fun to dig into those and find out. We're always open to ideas about new things to cover, new hacks. Don't be bashful. Share your projects. We'd love to hear about what you're working on. Again, tips at Hackaday. Driving engagement. So live events. Have you enjoyed Supercon so far? All right. So I always look at this one. I I always look at Supercon as the way to recharge your batteries. So you go through an entire year. This is kind of like the end of conference season. If you've been exhibiting or like building things, you're like super exhausted. And really, like now's the time when you need to start planning for the next thing that's coming ahead. A lot of product cycles are going to start up in the new year. And so coming to live events like this and just getting reinvigorated, seeing the people you haven't seen, try the things out in the hacking area that you didn't get to try just for fun. I think it's really important for us to get together in person and support each other like this. You can do it online, you can visit online, but there's nothing like having a coffee or staying up way too late with your friends. And the spontaneous things that come up that allow you to form new engineering teams and new product teams, I think are really important. This is not the only event that we do. We did a huge conference in Belgrade this spring. It was super oversold, and people were really cool about it and came in from many different countries. We had a badge. We started at 9 a.m. We went to like 3 a.m. The badge hacking ceremony started at midnight. It was just amazing and a great amount of energy. And kind of the same goals. Let's get people together. Let's recharge their badges. Let's be really excited. Have a bunch of talks, a bunch of workshops, and kind of elevate that knowledge. On the kind of the less formalized side, we've been doing these unconferences, which is you all come for one day. We'll book a place. We'll have AV set up, food and drink, and a lot of fun, but you have to be ready to speak for 7 minutes on something that's exciting you right now. And whenever we put this out there, people are like, I really want to come, but I don't want to speak about something. And it's like, that's the whole purpose of this. It's not something where you put in a call for proposals 2 months ahead of time. It's something where you just get up and wing it, and people are super supportive. I think what you want to do is break down, again, normalize that. Like getting up and talking about what you're doing and being excited about what you're doing is key to spreading scientific literacy and spreading excitement in engineering. This one was in Dublin and had great turnout. We also have really successful local meetups, and one of the biggest ones is Hackaday LA. It meets once a month in the design lab right next door. I'm kind of surprised by, I've met 6 or 7 people who are from the area and haven't heard of it yet, so definitely check that out. If you are not from LA, make sure if you're ever visiting, check the schedule and see if it's happening. You're certainly welcome to stop by and have fun. There are organized speakers. And one of the greatest things that has happened over the past year is we've started live streaming and posting all of those to our Hackaday YouTube channel. So if you don't already follow us, go to youtube.com/Hackaday and follow us for those. We are live streaming the conference right now. All the talks from this weekend will be on there. But obviously we understand geography is an issue. Not everyone can come, and so we love to host events that let people organize their own meetups. This year, again, we had the Hackaday World Create Day, invited people to have community-hosted meetups. We had over 100 throughout the world. Some people got together and put on like full conferences with speakers. Some got together for just a hackathon. Many of them got together and thought about their Hackaday Prize entries and formed teams and submitted. But again, it's just another way to bring people together and support each other. I also think it's really important that we support original discovery and we celebrate that and give people an outlet for it. I love to read about new research. And again and again and again, I am hit by the paywall where you can't get in. They're like, are you part of a university? And it's like, I'm not part of a university. I just want to read this like for fun, like as a hobby or for entertainment. And I think that should be possible. I also think there shouldn't be barriers for people to, when they have original discovery, to getting it published. And so last year at the Hackaday Superconference, we announced the very new idea of the Hackaday Journal. The full name is the Hackaday Journal of What You Don't Know. It's a new peer-reviewed open access journal. And over the summer, we had our first accepted paper make it all the way through the peer review process. This is by Ted Yapo, who's in the back. Ted, did you already give your talk this weekend? It's right. It's next. Stick around for Ted's talk. I think this is Ted's talk. I think this is a really amazing use of a tool that is not cutting edge anymore, but is still around because tools cost a lot of money, and Ted figured out a really novel, inexpensive, and amazing way to make that tool a lot more useful. It is really important to have this outlet to share this discovery because it will become useful for other people. And having an open access fixes that problem I said before of like locking people out of this research. We have other papers that are in the peer review process, and we have a few others that we know are coming in as submissions, but we are still looking for more. So please check us out at journal.hackaday.io. If you want to, float an idea by us before you send the full submission, that's fine. We really would just like make the connection and get more of those into the pipeline. So I mentioned that I would open and close with an anecdote, and I hope the subject of this anecdote doesn't mind. I know he's here today. So there are all kinds of ways to get involved in promoting the sciences and help building up scientific literacy and help getting people engaged in engineering and to up their skills. And I know this guy named Ben. And so Ben has like a serious engineering job, but Ben also makes cookies. And this is what he uses to make the cookies, and he mixes them up one at a time and bakes cookies of 12 different recipes at once, and then like notes down what makes the best cookies. And the thing is, Ben also makes circuits on like oddly shaped plastic things. This is a new one of his. And he publishes all of this stuff on his YouTube channel, Applied Sciences. And I was watching this because I watch all of them, they're amazing. And I got to this screen and I had to pause it. Look at all of these samples that he ran of this process, like laser cutting and then chemical deposition of copper on these circuits. Like, it's amazing. What he's doing is it's a long process to make this, and he's going through and tweaking all these designs. His talk is actually at the end of today in this hall, so you should check it out. But the thing that I look at this is, what he's doing is he knows what he wants to do. He comes up with an idea for it, and then he tries all these little different tweaks to it to see what works the best and keeps good records of those. It's almost like he's using some type of established method, but instead of beating you over the head with that method, he's just doing it by example. So he's normalizing this process of going out and inventing stuff in a way that has been proven to work and be really successful. And I think he's among many others that are sharing their work, being really excited, and not making it like a formal, like you should learn something for this. It's just implied, like this is what people do, is they go look at really interesting work and they learn from it. And so learning really should be entertaining. And so don't self-eliminate on the things that you're doing. Don't say nobody wants to hear about this. This is too simple. Everyone's done this. People have done this before. People learn things in different ways. The other thing is you'll get better by trying to teach it to someone else. And I was just talking to Quinn Dunkey yesterday on an interview, and one of the things that she said is it's been proven through research that you do a better job of teaching people if you just learn the skill yourself because it's so much fresher. I can't speak to that. I haven't seen the research, but I think it's a really interesting data point that I'd like to look a little more into. So normalizing scientific literacy is awesome, and you can do it. Just be excited and share that excitement with everyone. That was the anecdote. Let's talk about the serious stuff now. So there are a lot of problems facing the world, and I think it's really easy to be downtrodden about them. You could think that we're slipping into a dystopian society, and I don't think that's true. I think any point across human history, you could have had the same thought. But the challenges ahead of us are serious, and we're going to need serious people and serious solutions in order to fix them. I think our society is miraculous, but we need to ask ourselves, is it built on harmful environmental practices? Is it built on fair and equitable practices? And do we feel good about the way that we live? And if we use those, if we're really true to ourselves on those ideas, we can start finding ways to change it, to start moving the boat, but we got to do it pretty quickly. So I think one of the things that's super important is that we energize the people that have the skills right now to fix these problems. But those people will get weary. They need someone to take the pressure and take the strain off of them. And so we also need to grow up an entire generation of people that will take it over and do long-term fixes on like a species level for our planet and for our cultures. The thing is, we can't do any of that if we don't have broad-based support from society underneath, and that's where scientific literacy comes in and promoting it. So do anything you can in your community to get out there and talk about the benefits of science and knowing science and playing with it, and break down those barriers to get into it and show it as something that's entertaining and exciting. We need the support of our friends and neighbors. We need the support of our business owners. We need support of educators. We need support of politicians. And in order to get all of that, we're going to need the support of the electorate. In short, there is no stone that we should leave unturned in building awareness and promoting scientific literacy. These problems can be solved, and it won't be easy. But as a society, we need to make sure we do everything we can in all the parts that I just talked about. Let's motivate the brilliant people who are going to devote their time and their talents to these solutions. Together, let's all be Hackaday. Thank you.